The soda fountain. It serves up soft drinks. Simple as that. But it's not really that simple. The truth is, a soda is a seemingly impossible marriage of water and carbon dioxide, or CO2. Two substances that simply do not mix. The fountain is forced to make each soft drink by doing the impossible, trapping CO2 in water. To make this happen, the fountain does whatever it takes, and it takes a whole lot of pressure. Okay, so how does it work? The soda fountain, the machine that makes the soft drinks. To make this impossible mixture possible, it relies on 6 syrup pumps and 6 boxes of syrup. A pump is connected to the water supply. A carbonator, a cylinder of CO2, and taps. When a tap is pushed in, the pump sends water to the carbonator. The cylinder also sends CO2 to the carbonator. Its job is to mix these seemingly incompatible substances to produce carbonated water. Once that miracle is achieved, the carbonated water is sent to the tap. The syrup pump sends in the chosen flavour. The syrup and carbonated water mix together right before they pour from the tap. And that's it. The soda fountain has just made a soft drink. In barely 4.8 seconds, water and CO2 have been mixed, flavour added, and your cup filled. But to understand how the carbonator manages to mix water and CO2, a little destruction is in order. The carbonator. It injects CO2 into water, creating carbonated water. But CO2 and water are not made to be mixed. The shape of their molecules prevents them from forming any chemical bonds. Mixing the two means the carbonator must force the issue. How? By boosting pressure. That needed pressure is provided by the CO2 cylinder and the water pump. The cylinder supplies pressurized gas to the carbonator. The water pump adds pressure to the water and sends it into the carbonator. The meeting of water and gas happens inside the carbonator at more than 700 kilopascals. That's 7 times normal atmospheric pressure. This high-pressure meeting is extremely turbulent. The shaking and spinning help maximize surface contact between the water and gas. These extreme conditions allow the apparently impossible marriage of water and CO2 to happen. Molecules of CO2 separate themselves and then surround themselves with water molecules. What seemed impossible at room temperature happens under pressure in the carbonator. Gas has dissolved in water. This carbonated water contains 0.4% CO2. That's 16,000 times more CO2 than water can normally contain. Inside the carbonator, carbonated water has no bubbles at all. It resembles water. By isolating and surrounding themselves with water molecules, the CO2 molecules have completely dissolved in the water. But as soon as the carbonated water leaves the tap, atmospheric pressure goes back to normal, and water finds itself crammed with 16,000 times more CO2 than it can normally contain. The impossible mixture doesn't last. The CO2 molecules reattach to become gas once again. Slowly but surely, that gas leaves the water in the form of bubbles. The bubbles in a soft drink glass are no more and no less than CO2 that was trapped in liquid form, which can now escape by changing back to gas. 1 glass of soft drink contains 1 glass of water and the equivalent of 5 glasses of CO2 trapped in water. Once it leaves the tap, the gas starts slowly leaving the soft drink, bubble by bubble, until all that's left is water and sugar. The soda fountain. It makes each soft drink by forcibly combining CO2 and water. An impossible marriage, unless it happens under pressure.